In the next couple of modules, we're looking at properties of triangles and segments in triangles. And in the module on properties of triangles, we're starting with angles. On Monday, we did an activity exploring the angles of polygons, and so a lot of what you're going to see in this video is a bit of a review, but I want to make sure that if a student was absent for that activity, they still get the instruction that they need. Okay, so the explore activity for this lesson has us drawing a triangle and then tearing the angles off of it. And putting them all next to each other. And what you should notice is that they add up to a straight line. Straight line, straight angle, 180 degrees. So, in part B, when it says what seems to be true about placing the three interior angles of a triangle together, they add up to 180 degrees. So make a conjecture about the sum of the measures of the interior angles of a triangle. We've talked about this before. The sum of the measures of the interior angles of a triangle is 180 degrees. And there it is, the triangle sum theorem. And we've seen this property before. I complained when it came up before that they didn't make a big deal about it and put it in a nice little box. Well, now they've done that. And so we're going to prove the triangle sum theorem now. And in order to do that, we need an auxiliary line. And what that is just an extra line added to the diagram to help illustrate a property. So here, I'm starting the proof not with the given, but I'm starting with my auxiliary line, that I'm drawing a line, and I'm going to call it L, and it will pass through B and be parallel to AC. And the reason why I'm allowed to do that is the parallel postulate, and I'll talk a little bit more about that after we complete this proof. So it says that the measure of angle 1 is going to equal something, and that the measure of angle 3 is going to equal something. Well, we just drew a parallel line. And when we have parallel lines and they're crossed by transversals, remember from Module 4 that we end up with some congruent angles. So angle 1 is equal to angle 4, and the measure of angle 3 is equal to the measure of angle 5 because they are alternate interior angles. So my reason is alternate interior angle theorem. And then I say that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. And you can see that they're kind of condensing a couple of steps into one. They're saying it's the angle addition postulate, part plus part equals whole, remember? And the definition of a straight angle. So I mentioned earlier that the straight angle is an angle that measures 180 degrees. And so now we're saying that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Well, look at this equation and look at this equation. I've got three things being added together to equal 180. This angle 2 is still there, but what happened to angle 4? I put angle 1 in its place. Same thing with angle 5. I put angle 3 in its place. And when you put one thing in place of another that is equal to it, that's the substitution property. I mentioned earlier that I was going to clarify a little bit about the parallel postulate, and here it is. It's asking to explain how the parallel postulate allows you to add the auxiliary line into the triangle figure. So the parallel postulate states that there is exactly, that's messy, that there is exactly one line passing through a given point parallel to a given line. In the reflect question 2, it says, what does the triangle sum theorem indicate about the angles of a triangle that has 3 angles of equal measure? How do I know? Well, if the 3 angles have to add up to 180 degrees and the 3 angles are also of equal measure, then the measure of each angle is 180 divided by 3, which is 60 degrees. In this next explore activity, we're talking a little bit more about the angles of different polygons. And again, if you were here on Monday, then you saw this activity, or you did this activity without even realizing it. All right, so if I have one triangle, well, then I only have one triangle. But if I have a quadrilateral and I draw the diagonals from one vertex, I can take this quadrilateral and break it into 2 triangles. This is a pentagon, and if I pick a vertex to start drawing diagonals out of, I can draw one here and I can draw one here, and that's all the triangles that I can break this down into. 3 triangles. This is a hexagon. If I pick this vertex, I can draw this triangle, that triangle, and that triangle. So now this has 1, 2, 3, 4 triangles. This is a 1, 2, 3, 4, 5, 6, 7. It's a heptagon. And drawing diagonals from one vertex, I end up with 5 triangles. This is an octagon. And I have 1, 2, 3, 4, 5, 6 triangles. And in this table, they're asking us to identify the number of sides the figure has, the number of triangles it has, and determine the angle sums. And since I know that the angles of a triangle add up to 180, that's why you keep seeing this 180 here, because we've broken all of these figures into a certain number of triangles. All right, so Pentagon has 5 sides. There are 3 triangles I can break that down into. So it would be 3 times 180, and that would be 540. Hexagon has 6 sides. I can break that down into 4 triangles. So that would be 4 times 180, giving me 720. And we didn't draw a decagon up here, but I'd hope that you'd kind of notice the pattern here. The number of triangles is always 2 less. So that would be 8 times 180. And where's my handy dandy calculator? 8 times 180 is 1440. And some might say I kind of jumped the gun there. Do you notice a pattern between the number of sides and the number of triangles? So I mentioned it before. Number of triangles is 2 less than the number of sides. So I can express the number of triangles as n minus 2. And then in part D, it says make a conjecture for a rule that would give the sum of the interior angles for any n-gon, and it would be n minus 2, because that would give me the number of triangles, times 180. In a regular hexagon, how could I use the sum of the interior angles to determine the measure of each interior angle? Well, we found back here that the angles of a hexagon would add up to 720. So 720 divided by 6, if I know that each angle is congruent, which is true in a regular hexagon, then the measure of each interior angle would be 120 degrees. in Reflect Problem 4, this is one of my favorite kind of examples, they want us to determine the number of sides if I know what the sum of the angles is. Well, you would just work backwards. If I know that the sum of the angles, back here, equals n minus 2 times 180, well, then 3240 would equal n minus 2 times 180. And I'm solving for n. So we could distribute the 180. Add 360 to both sides. So 3240 plus 360 is 3600 equal to 180 times n. And when I divide both sides by 180, n is 20. Which means this figure has 20 sides. And so there it is, the polygon angle sum theorem, that the sum of the measures of the interior angles of a convex polygon with n sides is n minus 2 times 180. So if I have a figure like this, I can use this theorem in order to find this missing angle measure. And we did an example like this in the activity on Monday. So here, they kind of walk you through the whole problem. It's a nonagon, so it has 9 sides, so they plug in 9 for n and figure out that the sum of the measures has to equal 1260. So they add up all the measures that they know, and then plus x equals 1260, and then they solve for x. So the unknown angle measure is 158. In this example, they're asking to determine the unknown interior angle measure for a convex octagon in which the measures of the 7 other angles have a sum of 940. All right, well, n equals 8 because it's an octagon, so I would do 8 minus 2 times 180, so that's 6 times 180, and 6 times 180 is 1080. So I know that 940 plus x is going to equal 1080. And when I subtract that 940, I get that my missing angle is 140. So the unknown angle measure is 140. In this reflect example, they're asking how would we use the polygon angle sum theorem for writing a rule for determining the measure of each interior angle of a regular convex polygon with n sides. So a couple of things. We're finding the measure of each angle, and we know that all of the angles are equal. Well, the polygon angle sum theorem says that n minus 2 times 180 will give me the sum of all of the angles, and if I take that sum and I divide it by the number of angles, that will equal the measure of each interior angle in a regular convex n-gon. Take a moment and work through the Your Turn Below number 6. In this example, we're finding the measure of the 4th interior angle of a quadrilateral, and we know the other 3 measures. Well, we've already talked about how the angles of a quadrilateral have to add up to 360. So I know 360 has to equal 89 plus 80 plus 104 plus my 4th angle that I don't know. And then this is just algebra. So let's simplify. I have 89 plus 80 plus 104. This is 273 plus x. And then when I subtract the 273 from 360, I get that x is 87. Similar idea in this example. You may eventually memorize what the angles of a hexagon add up to, but you might not be there yet, so let's start with the formula. I'm plugging in 6 for n because this is a hexagon, and hexagons have 6 sides. And this is 4 times 180, which is 720. So I know that 720 has to equal 69 plus 108 plus 135 plus 204 plus b plus 2b. So let's simplify our equation. We have 69 plus 108 plus 135 plus 204 is 516. I can combine these terms. That's 3b. This is a 6. This is the letter b. Subtract 516 from both sides. And I have 204 equal to 3b. Divide both sides by 3. And b equals 68. However, notice the instructions asked for the unknown angle measures. Well, we found one of them because one of our angles was indeed b. The other angle, however, was 2b. So this is one of my angles, and then 2 times that is 136. So my two angles are 68 and 136. Always make sure that you're going back to read the question. Now we're coming back to specifically looking at triangles, and a little bit of vocabulary with triangles is that an exterior angle is formed when I extend a side of a polygon. So other kinds of polygons can have exterior angles and will have exterior angles. In this lesson, we're specifically focusing on the exterior angles of a triangle. All right, so this angle here is an exterior angle, and then the remote interior angles are the interior angles of the triangle that are not adjacent to the exterior angle. So in plain old teenage English, you might say that the remote interior angles are the angles of the triangle that aren't touching the exterior angle. That may be one way that you'd remember it. Okay, so in this diagram, I have a triangle with angles 1, 2, and 3, and they extended one side in order to form exterior angle 4. And I'd hope that you'd notice that angle 4 will be supplementary to angle 3 because they form a linear pair. So we know that angle 1 plus angle 2 plus angle 3 equals 180. That's the triangle angle sum theorem. But we also know that angle 3 plus angle 4 equals 180 degrees. Well, if both of these equations have this 180 degrees in it, well, let me put this another way. If both of these expressions equal 180 degrees, then they would be equal to each other. And notice what they have in common. They have angle 3 in common. So if I kind of lose that, then I can make a conjecture about the exterior angle, angle 4, and its remote interior angles. So the measure of an exterior angle of a triangle equals the sum of the remote interior angles. Let's say it's. And there you see it. Probably pretty close to word for word, the exterior angle theorem for a triangle. And even though we kind of sketched through the proof here we're going to do it a little bit more formally. So by the triangle angle sum theorem, angle 1 plus angle 2 plus angle 3 equals 180. Also, angles 3 and 4 equal 180 because they're supplementary and make a straight angle. By substitution, I know that angle 1 plus angle 2 plus angle 3 equals angle 3 plus angle 4. And if I subtract angle 3 from each side, this leaves that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So that means that the measure of an exterior angle is equal to the sum of the measures of its remote interior angles. In this discussion question, we're determining the measure of each exterior angle. So if this angle is 60, then this has to be 120 because 180 minus 60 is 120. Similarly, if this angle is 40, 180 minus 40 is 140. Oh my goodness, how am I supposed to find this exterior angle when they didn't give me this interior angle? Oh, how convenient. I know the triangle angle sum theorem. So 60 plus 40 is 100. 180 minus 100 means that this angle here is 80 degrees. So this exterior angle is 100. So I found the three exterior angles, and it's saying add them together. Okay, so 100 plus 140 plus 120 equals 360. And I hope you notice, geometrically thinking, that 360 is a really important and powerful number. And it's wanting us to explain. So let's think about it. We know that if A, B, and C are measures of the angles of a triangle, then 180 minus A plus 180 minus B plus 180 minus C would equal the sum of the exterior angles. Well, that's a whole lot of 180s, so that's 3 times 180 minus, and I'm going to kind of factor out a negative out of these three things, A plus B plus C. Well, 3 times 180 is 540, and A plus B plus C is 180, and that's 360. So let's use exterior angles to solve a couple of problems. In example 3, part A, they're asking to find the measure of angle B, so make sure that you realize we're finding the measure of an angle. We're not just solving for x. So we know that this exterior angle equals these two remote interior angles added together, so that's what they did here. And then they simplified, they combined these like terms, and then they solved. So then they took that 21 and plugged it in for angle B, and they found that the measure of angle B was 103. Similar idea in part B. I have this exterior angle, and it equals the sum of these two remote interior angles. So 3x minus 8 equals x plus 92. When I subtract x from both sides, I have 2x. I add 8 to both sides, I have 100. So x is 50. And the instructions were asking me to find the measure of angle PRS. So PRS is this angle. So 3 times 50 minus 8. That's 150 minus 8, which is 142.